so bright. Good morning. I'm not usually used to being up at this hour in the morning, but it's very nice to meet you all. Well, firstly, very great thanks to Satish for inviting me, and thanks to GopherCon India for having me. It's amazing to be here. Surprisingly, this is my first time in India. I've been trying now for about 30 years to get here. This is the first time I've succeeded, so thank you very much. Right. So my talk is entitled Ethereum, Why Go There? Yesterday we had a workshop on what I call hacking the Ethereum blockchain in Go. So the notes of that will be online. So this is not going to be a wildly technical talk, partly because, okay, can I have a show of hands? How many people actually know anything about blockchain? That's not bad, but it's still sparse, right? It's like a mapping rather than an array. So I'm going to give you an introduction, really, into what the blockchain is about, and really why being a Go developer is a great thing if you want to work on the blockchain. And after that, I'm going to really give you a feeling of why I feel that Ethereum is the blockchain to work on. Okay. Right, so what I'll do is I'll introduce myself a little bit. We'll go through what a blockchain is in roughly 5 minutes. A little bit about what Ethereum and smart contracts are. Why I am really happy that the most important code base for Ethereum is in Go. And from there, we'll just go through 2 or 3 things that Ethereum is being used for, or the blockchain in general is being used for. Right? So, me. Okay, I'm English. They kicked me out of the UK because I don't drink beer and I don't watch football. Yes, I started programming in 1968 because I used to get into trouble at school, and my teacher heard that one of our teachers had a computer class, and he asked me to go to there to keep me out of trouble. Didn't really work, but anyway, I've been programming since then. For many years, I worked in machine vision and instrumentation, and I started on the blockchain in 2014. And since then, my life has been totally insane. Right? So I'm now working at a company called Hello Gold. We're in Malaysia. I'll mention this a little bit more at the end, but working deep in the blockchain at the moment has made this probably the longest year of my life. My last year has been the longest year of my life. And technically and intellectually, probably the most challenging and rewarding. Right, so the blockchain in 5 minutes. Here we go. What is a blockchain? It's a load of signed transactions put into signed blocks, added to a list by signed links, which is spread over a huge decentralized network of many computers. It's like a peer-to-peer network, in a manner that everybody agrees that they all have the same state. They all agree on the state of the blockchain. Was that 5 minutes? No. Okay, let's a little bit more detail. So what's a transaction? A transaction really is anything that goes on between one party and another such that something changes, right? So, for example, they always talk about Alice giving to Bob. So let's say I give Alice $100 or something, and I say, well, happy birthday, Alice. I give her a little message to say why I'm doing it, right? You can imagine that, in a traditional web-based system, we'd be calling a server, and I'd be calling a function to say send value to, and then we say who it's from, who it's to, how much it is, the message, right? That would be and then at the back end, you'd implement something to make that do a transaction. Yeah? Now, this is where it all falls down. Okay, so I just happen to like quoting John von Neumann, and it's a nice long quote, but if I were to change the first comma in there to a full stop, how many of you would notice? How many of you are paying attention? You'd notice, I love it. Right, so we've got one person who would notice. So part of the signing is to make sure that nobody changes anything. And the first part of that, of course, is something which I trust that a large number of you are familiar with, which is hashing. Right? So if you hash a piece of data and make a very small change, the hash value should change dramatically. Right? Do you agree with that? Yeah? If you say no, I'll demonstrate. But, okay, so I demonstrated this yesterday. I'm afraid when my notes go online, you won't be able to do this because we don't have the right back end. But anyway, so you hash something, one small change, that comma changing to a full stop, and the value changes completely, right? Now, if we encrypt that hash value using public key encryption, right, then not only do I have a value there that proves the data hasn't changed, it also proves it's from me, right? And it makes it unforgeable, right? So, public key encryption, just in case anybody hasn't come across it, you pluck a random number from the air, a truly random number, right? A large random number, so there's virtually no chance of having any repetition. A bit of mathematics from that will give you the public key, which we also call the address in this case. So something encrypted with that private key can be read by anybody who has the public key. Conversely, you can derive the public key from that which was signed, or that which was encrypted, okay? So if we encrypt that hash, firstly, you can tell the data hasn't been changed, and secondly, you can prove who actually put that transaction there. Right. So this is basically just a diagram of that, right? So one side generates the hash, and the other side, everybody else verifies that hash. And we stick it into blocks. So this is just like a page on an accounting ledger, except we have a signature on every line. Well, you have that quite often in accounting ledgers. It's just that this is more unforgeable. You have a link to the previous page, so that if this page is valid, then the previous page should be valid. And you sign the whole block. And then the next block comes along and you do that. And so it is expected that you have a very large number of nodes who have, up until now, agreed on the state of this chain of data. So a new one, someone proposes a new block, and we agree that firstly this links to the previous chain that we've all got, and that all of this is valid. We verify the signatures, right? So what the whole consensus mechanism is designed so that on this peer-to-peer network, everybody agrees on the state of the data. In fact, everybody has the data, right? All of the nodes on the network have a copy of the data. No one node makes all the decisions. It's a group consensus, right? Which means that everybody agrees on the state of the blockchain. Of course, if you don't get an agreement, you get what's called a fork. These have happened in various times, and you tweak the consensus mechanism to make sure it gets better. So on the Ethereum blockchain, the foremost block explorer is called Etherscan. Down the right-hand side of it, you can see all the blocks coming in. On the left-hand side, you can see the transactions. You can get quite a lot of detail about the transaction, who it's from, who it's to, what it's transferring. Now, what this means is, of course, that all those records are public, right? Because everybody talks about blockchain as like cryptocurrency, crypto this, crypto. The only encryption that goes on in most blockchains is creating the digital signature. All the information is public, and that is what gives the blockchain its value. It's the fact that anybody can audit this, because we start off with one transaction and another transaction and another transaction, and as you know from common accounting systems, your balance is the sum of all the transactions that have involved you. Right? So the question now is, how do you access this? A lot of people talk about digital wallets, right? And one of the most frustrating things you will find is, with blockchain, is that you get most people who play around with cryptocurrencies don't even understand what they're playing with. And they say, how much have I got in my wallet? And if I transfer it to another wallet, will it all go safely? Right? And look, yeah, and they hold up a hardware wallet and say, you know, all my tokens are in this wallet. You know, and you open it up and there are no tokens in there. Because really, all a wallet is a means of holding your private key, which allows you to control an address on the blockchain. Right? And the blockchain on all of these nodes contains your balance by a summing up of all of the transactions that involve you. Right? What we normally call a wallet will perform one of a few functions. It will manage your keys. You can have multiple keys. It will allow you to create transactions. It will allow you to sign transactions and send them to the network. So, there we are. That is my blockchain in 5 minutes. Was it 5 minutes? I don't know, roughly, right? So what makes Ethereum something special? Well, there are two things that make Ethereum special, one of which I'm going to defer right to the very end. But from a technical perspective, what makes Ethereum special is, well, so remember I sent Alice $100 for her birthday, right? And you remember what I told her to do with it? I said, go and buy yourself something nice. I may not have been incredibly specific, but I could have been, right? I actually gave Alice an instruction, right? I gave her an instruction. I told her what to do. Now, this is, of course, in a byte field, a field of bytes, right? And now, when you start thinking a field of bytes. What can we do with that, right? You think byte codes. You think, well, if you're old like me, you think about UCSD Pascal. Those of you who may be a little bit younger, which I think is probably 99% or 99.9% of you, will think maybe .NET or Java, right? And then you think, well, if we can encode something in those bytes, we can have a compiler to create them and an interpreter to interpret them, right? That interpreter will be a virtual machine. We think we could do something with that, right? We could actually start building a scripting or a programming environment. And then we think, well, if we can actually make it so that this code is run all across the network, and we can have function. We can actually create big bits of this with function routing. I'm going to be English for a minute, routing, otherwise routing to our American friends. You know, so that you can actually define functions in there, and we can have state variables which persist. You can do all sorts of amazing things with that. So one of the things we now have that Ethereum introduced is that if you send bytecode to nobody in particular, right? You don't, so it's no longer from me to Alice, it's from me to, right? Then it gets put into a special place on the network. It gets given an address, as if it were a person, as if it was a normal account. But it gets treated very specially because I can send transactions to it just like I can to Alice. Right? Now, all of that becomes agreed and transparent. And I don't know how clear that is, but that is actually one transaction which is calling a function on a smart contract. Right? So by putting first of all, I create a smart contract by compiling my bytecode, sending it out to the blockchain, it gets given an address. Then other people can interact with that by sending a transaction to it. Now the data that they send will be function headers, it will be parameters, which can cause a change in the data space of that contract. Right? And that becomes something that is incredibly powerful. Because at the end of the day, Bitcoin and everything else that came before are essentially one-trick ponies. All you can do is, if you have got one Bitcoin, you can send part of a Bitcoin to someone else, or you can receive part of a Bitcoin from them. What we have with Ethereum is a system where I can now have a program running on the blockchain. Now, this program is running, as I mentioned, on every single node of the blockchain. Everybody will agree upon the state of that program. Everybody will agree the next transaction alters the state of that program. And what you can do with that is, well, I think my answer to that, when somebody said, well, what can you do with that yesterday, my answer is, well, what can you do with Go? You've got a programming environment. You've got one smart contract that you can interact with. This smart contract can also send transactions. It can send a transaction to a person. It can send a transaction to another smart contract. You've got a system where, really, from having been launched at the end of 2014, people are just starting to explore it. And millions of dollars have been, millions, probably billions of dollars have been poured into it. Some of the best researchers are working on it. Millions of people have used it for fundraising, thanks to the first building block that was created, which is called the ERC20 token. Right? Now, the ERC20 token is basically a balance sheet in a smart contract on the network, because if you can build an accounting system, you can build a mini accounting system in a smart contract. And you can launch yours, I can launch mine. You've got your value, I've got mine. We can all have our own virtual currencies. So, where does Go come into all of this? Because I may have started programming in Fortran, but in my programming life, my happiest times were spent probably from 86 to 96 when I was programming in Modular 2. And from when I discovered Go about 4 or 5 years ago, I can't remember exactly, when I started playing with it and thinking, this is nice, it's familiar, it's elegant, right? So where does Go come into all of this? The first thing is that the reference node implementation from the Ethereum Foundation is written in Go. Right? So, like, I'm sure at the moment, as Go programmers, we're all proud about things like Docker and all these other things, you know, are written in Go. Right? You can add the Go Ethereum client to that list of things that you are proud of because it is an excellent code implementation. And once they did that, they then took that implementation and designed it so that you can actually link into it. I mean, the first one was like pretty closed, and then they started re-looking at it and saying, okay, now how can we make it so that other people can leverage on this? Now, most of the people in the Ethereum space concentrate on either writing smart contracts, or they work on the browser side, which would be in JavaScript using a framework called Web3.js. But the Go developers figured out that not everything is going to come from the browser, right? So, you need server-side access as well. And that's why they started opening it up and building frameworks. So the reference node implementation is called Go Ethereum. You can find it on GitHub, right? GitHub Ethereum, Go Ethereum. Now, I said I started working on blockchain in about 2014. I started working on a code base called Monero. I worked on something called Stellar, and then a custom one for the company that I was working on. And it was all in C++, and I think the word nightmare comes to mind, really. Because there was, blockchains were all about transparency. Blockchain code bases are very convoluted and very hard to navigate because the key developers all bring in their favorite libraries, right? And if on a Linux system you install something and you don't know where the source code is, and it's all magic linking, and you can't follow it through. And compared to that, the day I opened up and had a look at the Go Ethereum code base, it was a little bit like looking at poetry. It really was. That you can read it, you can understand it, you can follow it, you can follow the dependencies, right? So it's almost as if the crypto part of the other code bases is actually in trying to understand the code. That it's not actually so incredibly difficult, it's just that the code makes it look difficult. In the Go Ethereum code base, it makes it look simple. That literally, when I started, I just posted a request into one of the channels and said, how can I find out how to do this? And somebody said, well, just look in this file here. And I went in that file there and I looked at it, and within a couple of minutes I figured out what I needed to do. Right? As opposed to in one of these C++ things where you open up the file and you go, huh? Right? In terms of popularity in the crypto space, this was posted recently, which shows that the Go Ethereum code base is the second most popular in terms of forks, downloads. There is an incredibly active community maintaining and improving this. So it's very popular, it's very readable, right? A smart contract, I'm sure you can't read that, I certainly can't read it down here, is in a language called Solidity, which is significantly like JavaScript, but not JavaScript. It does have strong typing and a few other things, and now is really not the time to try and teach you about it. Yesterday in the work group, we had a look at, we implemented one, and then we very quickly towards the end we implemented a second smart contract. So it's JavaScript-ish. There are numerous development environments to help you with it, one of which is an interactive one called Remix, which is kind of like the Go playground, except it has the ability, once you've finished, you can deploy your contract. So, yeah, where does Go really come into this, though? Or why am I here, yeah? I guess that's it. And sometimes I wake up in the morning and I wonder, but this morning I knew why I was here, which was to share this. So, I thought I'd change the head of it. This was stolen from my notes yesterday, right? The bit of code up at the top is what I would have to do to extract data from one of the event logs if I was writing pure Go, right? It's still not incredibly difficult to get to event logs. It's not insanely difficult to post transactions and stuff like that. But the Gopher team want to make it easier for you to build your server-side applications. So they built a tool called ABI-Gen, which will wrap your smart contracts into Go objects that you can interact with really easily. So the top one, we're sort of like trying to extract all the bytes and stuff. The bottom one, we ask it for the log, and it gives us back an iterator that we can just go through all the logs. Or if we want to keep monitoring the incoming logs, it gives us a channel that we can get new logs as they come in from. I think I've probably put in way too much code here. So I mean, but that is the bulk of the code to look through past log entries. Right? And if you want to view current, if you want to read a variable from the contract, well, this will allow you to do that. Right? We can just read. This would allow you, with the contract that we put yesterday, to read the status of all the accounts. We iterate through the accounts, we iterate through the readings. It's incredibly simple. Certainly simple compared to doing this with any other code base that I have come across. And we can send transactions. There are run buttons here. I can demonstrate that this works. I'm probably not going to do that unless I run out of notes. Pardon? Yeah, if I run out of time, we'll do it. Right. I have run out of time. Okay, very fast, sorry. So we'll nip through all of that. Most important thing, I told you the last thing I was going to do was to tell you the second reason that I like Ethereum. And that is, in my view, the Bitcoin community is driven by greed. The Ethereum community, yeah, you get people coming in there looking at it as a license to print money, but you also get a lot of people who want to make the world a better place. You've got the UNHCR developing a system so that from their central office they can ensure that aid gets right to a refugee in a refugee camp. They track the funds, they track the goods, right down so the refugee walks into a store in the camp, scans his eye in an iris scanner, the merchant gets paid directly, funds don't get lost in corruption. With Hello Gold, we have our root in the Asian financial crisis. So, sorry, we call it the Asian financial crisis. For you, it should be the Southeast Asian, because I don't think it really hit here. It came out of Indonesia, so the people at Gojek will know absolutely about this. The rupiah went down to about 1/10 of its value. The Malaysian ringgit went down to about half of its value. Thailand had equal problems. And we started looking at a way to allow ordinary people, not rich people. Rich people have got a lot of options, but ordinary people don't have a lot of investment options, certainly in many countries. Some people don't even have bank accounts. In the Philippines, only about 15 to 20% of people have bank accounts. I don't know what it's like in India. Right? So how can you help these people preserve any savings that they've got? And with our with our CEO, who used to be the Chief Financial Officer of the World Gold Council, he came up with the idea of allowing people to save in vaulted gold. And we work with partners who are with like the largest supermarket chain who have a credit department. So we allow people then to borrow again, collateralize their gold with a fair system. Right? So pawnbrokers are supposed to, if you can't repay your loan to a pawnbroker, they're supposed to sell the item and you get back any balance, but usually they don't. Well, we can enforce that with Hello Gold. Right? So you can loan against gold if you have a crisis. GiveEth is run by some amazing guys. They built a framework that charities can ride upon. So they can raise funds with GiveEth, but also the donors can hold the team accountable by only releasing those funds if they reach milestones. Sentinel Chain, which has just launched. One of the problems, like in the farming community, is that if you've got a factory, and you need a loan, the bank will give you a loan because you can collateralize your factory. If you've got a farm, you can't do anything like that, right? All you've got are cows or chicken or whatever you've got, right? And you cannot, it's very hard to raise land. So Sentinel Chain has been developed to allow farmers in particular, I think their first target is Bangladesh, to collateralize their livestock so that they now can get liquidity to allow them to develop their business. So, as a summary, there is really a special niche for Go programmers in the Ethereum space. I've had people come to me who need to push 13,000 transactions within the next 24 hours. And if they were using any of the other tools available, they would be dead. Using a piece of code that I could whip up in typically half an hour, I've managed to push those 13 transactions in less than 4 hours on the live network. Okay? And I can build stuff that just doesn't have the scalability or the performance. If you're using the JavaScript or the Node.js's and so on. And you will have an incredible set of tools that you can use. And finally, I would say that if you really get involved in the Ethereum community, your lives will probably never be the same again. All right, thank you very much.
All right, thank you, Dave. Any questions? I think we have time for one question. Okay. Oh my God.
Thanks, Dave. I'm relatively new to Ethereum and blockchain, virtually no knowledge of both of them. A couple of questions I have. First is, you spoke about certain nodes holding the information in the block, in terms of block in the blockchain, and they arrive to certain consensus. Now, is there a definite protocol amongst themselves to arrive to a certain consensus? And if yes, can these or this protocol be programmed?
Well, firstly, it is the entire thing about a blockchain, it is driven by computer science and mathematics and nothing else. In most blockchain implementations, you, with a computer, can start a node, which means that you are involved in the consensus. You can opt also to do what's called mining, which in some blockchains it requires a lot of power, in other blockchains it doesn't. Pardon me, wake me up, it's 11 o'clock. Right, sorry. So You can optionally take part in mining, which is assembling the blocks and putting them out for public approval. But the entire consensus mechanism is a programmed thing. It's a peer-to-peer network. The consensus is built in, right? Now, I have not particularly gone into the tech details in great depth on that, mainly because I've had too many other things to do. But I can assure you that if you wanted to look through the Ethereum code base, you would probably, with a bit of time, be able to understand that.
Okay, I know there are a few other questions, but Dave is hard to miss with that hat. Catch him over tea and the rest of the day. Speaking of tea, tea is served outside. We will regroup in exactly 20 minutes. Thank you so much, Dave. It was a pleasure having you here. A loud round of applause, please.
Pleasure being here. Thank you.